All right, let's get started. Welcome to the Gardener review meeting. Today we will look at the 1.136 release. And we have quite a bunch of topics since this release cycle was also a week longer than usual. So we start with Oliver and an older PR about kube-apiserver access logs. That was already released in a previous version, but we hadn't had a chance to present it yet. Then we have Max with an enhancement in provider-ironcore about GPUs. I will show a new feature about manifest propagation to shoot clusters. Then we have Stoyan with the InPlaceOrRecreate VPA update mode webhook. Sebastian will talk about the seamless overlay network switch. Shafiq will show the feature for the custom CA bundle support for downloading Helm charts. And finally, we have Tim with an enhancement in the shoot cleanup about leftover toleration. All right, then Oliver, please get started with the first topic.
Okay, yes, good morning. Unfortunately, this is going to be a short topic because my demo is broken. Like too many changes between the version 133 and 134. Let's get started. Yeah. Okay. We have this famous topic, Istio TLS termination, and aka layer 7 load balancing. And while we are testing the feature, we found out several things. And one thing was that we don't see access lock in Istio for connections which go through the API server proxy. Requests to this local cluster local endpoint, Kubernetes default SVC cluster local. So there are no locks. But in general, when you have this layer 7 load balancing, you see access locks in Istio and with another pull request even in the shoot Plutonal. This is fixed here in this pull request. Before I can see is show you the status quo, but not the new status. So before there were like locks for the HTTP connect, but not for the request itself. And this is changed here in this pull request. And you see log lines like this in the logs of Istio and in Plutonal. I wanted to alongside with this, we also changed some minor things. It's not related to the logs, but we wanted to keep the endpoints configured in the same way, the normal kube-apiserver endpoint and the API server proxy one. Yeah, unfortunately, I cannot show you the thing because with the between versions 133 and 134, we also changed the registry. So we deploy it as Docker image right now, and I was not able to upgrade my cluster. So yeah, no demo today. Otherwise, you would have seen that those log lines appear once I update the cluster. Okay.
Okay.
Yeah.
Any questions?
Any questions?
Nope. Cool. Then thanks, Oliver. And over to Max for the experimental GPU support in provider-ironcore.
Good morning, everybody. Let me just share my screen. I hope you can see it. Okay, so as I said, good morning. Today I'm going to talk to you a bit about experimental GPU support in the infrastructure provider IronCore. Just to give you all a short refresher, how does Gartner work with IronCore? So in the context of Gartner, basically IronCore is just another infrastructure provider like AWS, like Azure, like OpenStack, etc. And this is thanks to the Gartner extension provider IronCore, which runs in the Gartner cluster and provides this. And so for me as a user of Gartner, when I select IronCore as the infrastructure provider, I can then specify the machine types that I want my worker nodes to be. And those are then, of course, exposed by the IronCore operator and the cloud profile specified. This translation between Gartner machines and IronCore machines is pretty straightforward because when compared to other of these providers, because IronCore also exposes a Kubernetes API for provisioning machines. So just a short refresher. Now to the GPU support in IronCore. First of all, why do we even want GPU support in IronCore? Well, the short story is, of course, we want customers to be able to use GPUs for their workloads, for example, if they want to run a large language model. And therefore, for us, our goal is to offer machine types which come with GPUs attached. So from a user perspective, we want this to be as simple as possible. GPUs should just be another capability that a machine class provides, like CPU or memory. And this is a rough sketch of what the API could look like, but that's subject to change. Now, the long story is a bit more complicated. In order to show what IronCore can do right now, hardware was sponsored by the Apero project for a showroom. And this is also the infrastructure that will be used by Gartner for the Sovereign Cloud presentation at KubeCon, together with NVIDIA in about a month. And here you can see that we have 4 hosts, which each have 8 NVIDIA B200 GPUs. So right now, for us as managers of this infrastructure, the central question, of course, is in which form do we want to offer this hardware to our consumers? And I will now walk you through a bunch of different options that we have and kind of give pro cons and say what we are working on. So first of all, we have the single GPU pass-through. Here, the GPU is just another PCI device that we can pass through to a VM. And the good thing is then that we can provide up to 32 VMs, so we can serve a lot of customers. But there are also, of course, some downsides, because like a single GPU may not be powerful enough for some workloads. If you have a very large language model, then it may not fit into the memory of the GPU. And of course, it doesn't harness the full power that our B200 enterprise GPUs really provide. On the other hand, we could pass through multiple GPUs. We can give through up to 8 GPUs per VM. And that could, of course, support much more complex workloads because they can also connect together. But there's also quite a bit of downside because in the worst case, we could only provide 4 VMs, which is quite few. And passing through 2 or 4 GPUs is actually more tricky than expected because it requires coordination of the guest VM, which is a bit tricky because we allow customers basically to upload any image that they want. It also would require some coordination from the host or from a service VM through the NVIDIA Fabric Manager, which we would have to automate. And right now with one of our providers, VM providers, Cloud Hypervisor, there's also a problem that it really doesn't support setting the right PCI hierarchy. So right now, single GPU pass-through is implemented in one of the IronCore VM providers, while multi-GPU pass-through that's still being worked on. Now for the future, maybe there are some other options that we might consider. For example, we could even virtualize GPUs. So we could even offer more VMs. But there the problem is that this requires hardware and software support. For example, NVIDIA multi-instance GPU does this. And of course, this would also need to be automated. And the question also is if there really is a use case for this, if there's such small language models that fit into like a virtualized GPU, and if there's actually demand for something like that. Then the other thing is multi-GPU across hosts. As I've said, they can connect, and they can even connect, the GPUs can even connect across hosts. But there the problem is that this requires automation of the NVIDIA AI fabric, so network switches. And here you need to follow NVIDIA best practices, and we would require more switches than we have right now, and so it's currently not feasible. There's also the idea within IronCore that we can give out bare metal machines to customers one day, which also would, of course, include the GPUs in these machines. But this would first require us to move all of the IronCore services to the SmartNICs, and that's something also that is in the future. So this was all. If you have any questions, don't hesitate to reach out to us. And have a nice day.
Great. Thanks, Max. Well done. Any feedback to this slot before we continue?
Yeah, I had just a small one about the trajectory of this. How do we avoid vendor lock-in with NVIDIA? Because right now this seems very focused on the NVIDIA option, and I just want to make sure that when we design the APIs, that it's feasible for like an open vendor kind of design.
That's a very good point. Also something that we talked about when I said that we want GPUs just to be another capability like CPU and memory. Basically what we're doing under the hood is now we're designing or we have designed a kind of interface which allows us to claim certain resources. And so we have different adapters basically for different kinds of resources. That's the idea. Right now, as you said, it's very focused on NVIDIA because that's the hardware that we have, but we try to build it in a way that is also that can be extended later on. Yeah.
Thank you.
All right, then let's continue. The next topic will be presented by me. It is about the static manifest propagation from seeds to shoots, so this PR. And there's also documentation with this title if you want to look it up. So what is this all about? Sometimes operators would like to just roll out some static manifests to all the shoot clusters. For example, ABAP rules or quotas or whatever you can imagine that you just want to have automatically rolled out into all the shoots on a certain seed, maybe, or even on all seeds. Yeah, I will not go through the entire document. You can have some other examples here, maybe also networking policies and so on. And then the explanation how this works. And to show it, I will directly jump into the demo part. So what I have prepared here is one shoot cluster. I'm targeting it here. Here I'm watching the resource quotas. Currently there are none. And here I see the shoot reconciliation state. So what I have prepared is some manifests that I want to be part of the shoot. In this case, it's this resource quota and maybe also a cluster role. So whatever you can imagine you can put here. And yeah, what you then have to do is you have to place this as a secret. So the content of the static manifest should be placed as a secret in the garden namespace of the respective seed. So this I do with this command. I'm basically creating a secret from these files in the garden namespace. And then I have to apply a certain label so that the gardenlet can find it and can know that these are manifests to be considered. This is this Gardener Cloud Purpose Shoot Static Manifest label. And that's it. And yeah, when I then just reconcile the shoot, you see the progress on the right side, we should eventually see that, yeah, for example, this resource quota appears here in the cluster itself. So yeah, this is an easy way for operators to just roll out things they want to have there automatically. There's also the option, if we go a bit further down here, to target only specific shoots by having a label selector on the secret. So you basically specify it here in the annotation, static manifests and so on /selector. And then you can just have a standard label selector for the shoots that should get this these manifests. So all the shoots that won't have the respective labels will then be excluded. And yeah, we can also try that out. I think I have done it here. So I'm adding this label selector for label foo equals bar. And let's see if the shoot has this label. Yes. So if we remove the label now, and reconcile again, then the resource quota should disappear. Also check the secret in the meantime. It's gone. So this is the secret. Yeah, no special surprises here. Here are the manifests. I think you can also have multiple keys if you want. And here's the label we just added. And the purpose label for Gardenlet to find it. So this is already it about the feature. If you want to learn more about it, then I would recommend to go through this documentation here. And yeah, there are some important considerations that you might want to also study if you want to use it. For example, the most important one is that there is no templating in this. So this is explicitly called static manifest. So you cannot just inject dynamic values into the manifest you want to have in the shoots. This is really just for pure static configuration that you want to have rolled out. All right, that's all I want to show. Feel free to ask questions if you have any.
Just a quick question. If there are collisions, I mean, if the manifest creates a resource with the same name that already exists, how does this scenario be handled?
Yes, so these manifests end up to be managed resources in the shoot control plane namespaces. And with this, we have the standard health checks on the managed resource status that are executed by the resource manager and then later picked up also by the Gardenlet and transported back into the shoot status. So eventually this would be very soon visible that some of these managed resources will be unhealthy. In the end, this is a human operator task, so the human operator has to ensure that there is no conflict, of course. So maybe prefixing the resources with some unique name also could help. Okay, then I guess we move on. Next up is Stoyan with the InPlaceOrRecreate VPA webhook.
Yep. Hey everyone, just quickly share my screen. Okay, I hope you can see it. Okay, so over the past few months, I've been working, and the team as well, on providing a new mechanism for adopting the InPlaceOrRecreate update mode for VPA resources. So as a additional information, the InPlace update mode allows us to update the resources of pods without actually evicting it. So it kind of works in-flight updates, kind of. So for that, for the adoption of it, we decided to go with a resource manager webhook that gets enabled by the VPA in-place updates feature gate, both for Gardenlet and Gardener operator. So the webhook actually works on create and update events. So basically, whenever a VPA resource gets created or updated, it gets picked by the webhook and adjusted based on few constraints. The constraints are pretty much the update mode should be either auto, which is now deprecated, or recreate. And for shoot clusters, we focus on, not focus, but we edit only VPA resources within the kube system and Kubernetes dashboards. That's because we don't want to pick up any customer workloads and just target our own, like the out of the box that we provide. And for seed clusters, it's the other way around. All VPA resources outside of kube system and Kubernetes dashboards. That's essentially the shoots control plane component. So in addition to that, we have introduced a label that could be put on a VPA resource, which is this skip label. It's essentially saying the webhook that the VPA should not be updated. So that's about the webhook. In addition to it, we've introduced a Gardner-led and Gardner operator migration that runs on startup, because the webhook only reacts on create and update events. And for example, if a say certain workload takes longer than expected to get its recommendations updated, and you would like to speed up the adoption, you can just, I don't know, like rollout restart or restart the Gardner-led or the operator, like reconcile it, and it will emit either empty patches to all VPA resources, or it will revert the changes of the webhook. That's done based on the feature gate again. So if the feature gate is enabled, we are looking at these two labels here, the skip and mutated. The skip label, obviously, as said previously, it looks for VPAs that should not be updated. So if the VPA is labeled with that skip label, shouldn't be touched by the webhook, meaning shouldn't be touched by the migration script of the Gardner-led or the Gardner operator. The mutated label on the other side is responsible for not updating VPAs that have already been updated. So it's kind of a optimization here. The interesting part about these migration scripts is that when you disable the feature gate, it will actually revert the change of the webhook. Since the feature gate is still in beta and we would like to have this undo functionality, for example, if someone notices something strange with the behavior, you can always disable the feature gate, and those migration scripts could be like the Gardner-led and the Gardner operator could be restarted, and with the migration scripts, it will revert the changes of the webhooks, not the webhook. Yeah, sorry. So that's the main functionality here. Apart from that, we've also introduced a new dashboard for the VPA updater. So it now shows some basic scaling statistics about the amount of VPAs that we control and the operations that the updater is performing. So I can quickly show you like a quick demo of how it looks like. So for the local setup, it's already enabled not by default, but it's already enabled. So when you create a cluster locally, it's expected that all of your VPAs should be instrumented with the InPlaceOrRecreate update mode. So as a quick demo. So that's on the seat. Here I have like a single shoot and all of its VPAs are updated. And for the shoot, we can see that all of the VPAs within the kube system are updated. And I've created one demo namespace with a single resource manager deployment that has 3 pods. And we see that it's the update mode, it's not touched. As intended, the webhook doesn't update shoot resources that are outside of the kube system or the Kubernetes dashboard namespaces. Okay, so in addition, I have opened the dashboard here just to quickly show you around. I have a scale section that displays how many pods are with the InPlaceOrRecreate update mode that are managed by such a VPA, and how many pods that's the resource consumer that I have. So that's a pie chart here just for I don't know, quickly seeing the current state. We have another chart as a timeline to see how it changes over time. So here I created the resource consumer deployment. Here we can see some pods pending in place update. As we started, there were some resources that were updated. Here you can see the corresponding amount of VPAs. So that's the number of pods here, and that's the number of VPAs that are pending update. So the patterns should match. And the interesting part here is the successful, failed, in-place update and pod evictions. So in that case, we have only successful updates, but yeah, that's good for the demo purposes. Here are the kube system components here, and all of them have some amount of updates. So that's pretty much it for me. If you have any questions, you can always reach out in the channels or ask them now.
Okay, great. Apparently no questions. Then let's move on. Next up, Sebastian with the seamless overlay network switch.
Okay, then let me share my screen. I hope you can see it. So this is about a series of pull requests. So basically what we want to do in the past, usually when Calico and the AWS route controller and so on is deployed, they are deployed as managed resources. And at some point in time, the route controller runs and also the Calico runs. And when we update from overlay networking to non-overlay networking or native routing, we see that sometimes the Calico daemon set gets restarted before the route controller has created the routes, and that could possibly lead to disruptions or downtimes. And that is what we want to address here. So how we want to do that, or how we did that, we had a lot of discussions because there were different possible solutions to add that dependency to wait for the route controller. And the best solution which we've implemented now is that we also add, so there's a node condition, network unavailable, which is used by Kubernetes and set by the cloud controller manager. And in our route controller manager implementation for AWS, we haven't set that. So we addressed that. We also did it in a similar way, like the cloud controller manager did it and improved it a little bit. We also added that upstream to the cloud controller manager, that improvement. And now it sets the route, and it also patches also the route condition if it was set by something else like Calico, which could also set the network unavailable condition. Calico then checks for that node condition, the network unavailable condition, and once the route are created, Calico knows that it can start rolling the pods. So we can go in a short demo. I have one cluster which runs with overlay networking. So here we have a watch on Calico, the Calico extension. Here we watch the AWS custom route controller. So we want to see that it gets first created, then that it updates the node condition for all the 4 nodes. We should see here the routes created, so that it's updated from Calico's running to route created. And after that was done, the Calico nodes should get starting rolled. So before there basically was a race, we saw sometimes that the Calico node pods got restarted before the routes were created, and now this will be solved, this pull request. So let us edit the shoot cluster, the overlay field, and set it to false. Okay, now the should get reconciled. And it's happening really fast. So we see that the custom route controller gets created. Then we can see here that it should, when the routes are created, we also see here that Calico now waits until the routes are created in the logs of the extension. Now the route controller has created the routes and it successfully reconciles the network, and the Calico node pods are now getting started. A first improvement of that is in the past, what we have also seen, if stakeholders had very large cluster with a lot of nodes and they want to switch to native routing, sometimes the resource quota in the infrastructure was not high enough. And with that change, we assure that we don't switch before all nodes have that, and we only and this only will happen if the route quota is high enough, because in the past they were already stuck. Then half of the nodes switched, and the other one couldn't because the routes couldn't create it. And yeah, this issue is now already solved with that change. It's now working for AWS. And we are also working on addressing that for the other cloud providers like GCP and OpenStack. There are already pull requests open, and then hopefully soon we can migrate without downtime to native routing. Okay, that's it from my side. Any questions?
Apparently not. Then thank you, Sebastian. And next one is then Shafiq with the custom CA bundle support for the Helm registries.
Thanks, Rafael. Let me share my screen. Yeah, so hello everyone. I'm going to present this PR today, which is about supporting custom PKI registries for the extensions, like so where we pull the Helm charts from, so those here registries. So we already support pull secrets for them, but yeah, custom CS were not supported yet. So with this change, yeah, the first step is to create a secret with the CA bundle and the key bundle.crt in the garden namespace for the extension operator extension resource. This should be runtime garden, and for the controller deployment, yeah, this should be yeah. And then we can reference it in the extension. So this will come like under the OCA repository. There will be the CA bundle secret ref field. And similarly, even virtual cluster admission application, and this is admission runtime, and we also have extensions here, and all of them have the same OCA repository field, so they inherit also the same secret ref. And similarly for controller deployment also uses the same OCA repository field. So yeah. So for a short demo, yeah. So this is the extension, networking Calico extension. I have replaced the extension image with my custom image, which is using a custom CA. So this registry is using a custom CA. So if we check the extension status now, we can already see here that yeah, so there is this error which says OCA chart cannot be pulled because certificate is signed by unknown authority. And similarly, if we check the controller installation as well, this will also say the same, because this also comes from the extension. This is created by the extension controller, and Gardelet is using it. So I will now create a CA secret which has the key bundle.crt and this label gardener.cloud role OCA CA bundle. This is needed for this secret to get copied to the seed namespace in Virtual Garden. So let me create this secret, and then we can also reference it in the under the extension OCA repository and with the secret ref name. And if I go back and apply this secret, let's see. So now in the virtual garden, if I try to get secrets in seed namespace, we can see that it already got propagated here. And if I get the extension network in Calico, now we can see that everything is correctly applied. And similarly, if I check the controller installation as well, we can see that all the changes are rolled out properly. So in the future, so this issue is actually, this PR is actually only solving one part of a bigger issue. So the first part is supporting custom PKs for extension, the garden operator and gardenlet. But then this also needs to support node provisioning for pulling the image of garden node agent during node bootstrapping. So one PR will follow for this later. Yeah, so this is the parent issue. Yeah, so if there are any questions. If not, then back to Griffin.
Yeah, thanks, Shafiq. And we have one more topic for today, the last one presented by Tim about the leftover toleration during shoot cleanup.
Hello, everyone. So we brought 2 improvements for the shoot cleanup in that release. So what is the shoot cleanup? Actually, the shoot cleanup happens when a shoot is deleted, and then the gardenlet tries to delete, let's say, well-known objects in the shoot cluster, like services, PVCs, deployments, and so on. And we experienced 2 situations where this stuck, and improve that. So I want to jump directly to the demo because I can show you what this is about. So I already triggered a shoot deletion. We're actually in the middle of the shoot deletion, and for the purpose of this demo, I built in some error that stops during the cleanup. So the first situation that we experienced is that we had some orphaned resources in the shoot cluster. So resources that belong to a namespace which is gone. So on the right side, I have the shoot. And if I look at the namespaces, there is like this custom test2 namespace. Obviously, there was a test namespace, probably. It is not listed here. But if I list the services in the test namespace, which used to be there, I see that there's a service. So this is the orphan resource. And what you can already test is to delete that, or we can see that this one is in deletion. It has a deletion timestamp, but it is not gone due to the finalizer. And if we try to remove the finalizers, then it will say that the test cannot be found. So this was the first situation that we noticed. Gardenlet was not able to forcefully delete such an object, and the deletion was then stuck forever. Operators needed to intervene in order to resolve the situation. And the second one was that during the deletion, it could be a case that some, let's say, external controllers or processes constantly create objects in the cluster, and thus the gardenlet finds still objects of that kind, and also deletion is blocked here. So what we can since we're in the middle of the deletion, we can somehow fake that. Let's say, so I create another service. It's called leftover in this test2 namespace. So what this now has, is of course newer than, it has a newer timestamp than the timestamp when the deletion was triggered. And when was the deletion triggered? We can check we had it here. I can check the control plane namespace. So the cleanup was triggered at this time, 8 o'clock around. And then, of course, this one is newer. So let's continue with the deletion, and we should see that the GardenNet then tolerates two objects being present in the cluster and continues with the deletion. So it should take a little moment. Okay, then it continues. So it accepted that the objects are in the cluster. It prints out those objects in the logs. At least the metadata, it's saying that we have a leftover object in an unknown namespace. So this was the service, right? And the second use case was that it is ignoring a leftover object that was created after the cleanup start time. And it's also, this leftover in the namespace too. Okay, and with this, the deletion will continue until the shoot is eventually gone. Okay, that's already it.
Just to be sure, so this annotation that you set there, continue equals true, is just for the demo purpose to not have the fake error anymore, right?
Yes, it was fabricated so that we can hold the deletion for this demo and continue. Yes, it's just for this demo.
Yeah. Okay. Cool. Any other questions to that? Nope. Then thank you, Tim. And as said, this was the last topic for today. So thanks everybody for joining. Next week we have a special occurrence for the Kubernetes 1.35 release. So we will focus on the changes there. And then in 2 weeks we continue as usual with the regular 2-week cadence of the new Gardener release. Okay, then thanks for joining and have a good time. Bye-bye.
Bye-bye.
Thank you. Bye-bye.